मित्रों, आज हम बात करते हैं क्लासिफिकेशन ऑफ एलिमेंट्स इन पीरियोडिक टेबल एंड पीरियोडिसिटी। सबसे पहले फर्स्ट ऑफ ऑल वी विल डिस्कस व्हाट इज पीरियोडिक टेबल। A table which classifies all the known elements in accordance with their properties in such a way that elements with similar properties are grouped together in the same vertical column and dissimilar elements are separated from one another. Mendeleev's periodic law and periodic table. Physical and chemical properties of elements are a periodic function of their atomic weights. According to Mendeleev, the physical and chemical properties of elements are periodic function of their atomic weights. That means atomic weights of elements are deciding factor for their physical and chemical properties. Periodicity in properties. What is the definition of periodicity in properties? When elements are arranged in such a way that elements with similar properties are repeated after certain regular intervals, then this repetition of properties of elements is called periodicity in properties. Mendeleev periodic table. Mendeleev arranged then known elements in order of their increasing atomic weight and grouped together elements with similar properties in 8 vertical columns called groups and in 7 horizontal rows called periods. It means there were 8 columns and 7 periods in Mendeleev periodic table. Modern periodic law. Physical and chemical properties of elements are a periodic function of their atomic numbers. That means the properties of elements depends on their atomic numbers. Or in other words, you can say that atomic number of elements are the deciding factors of their physical and chemical properties. In this, elements are arranged in order of their increasing atomic number. The elements with similar properties are repeated after certain regular intervals on changing of periodicity or repetition in properties is due to the repetition of similar outer electronic configuration of elements. Modern periodic table. In modern periodic table, elements are classified in 18 vertical columns called groups and 7 horizontal rows called periods. It means in modern periodic table there are 18 columns and 7 rows. Again, the 18 groups are again classified in subgroups A and B and designated as first A, second A, third B, fourth B, fifth B, sixth B, seventh B, eighth, first B, second B, third A, fourth A, fifth A, sixth A, seventh and 0. Now we will discuss trends or variations in physical properties of elements. First, atomic size. In general, the atomic size of elements decrease with increase in atomic numbers as we move from left to right in a period. Means in a period from left to right, as the atomic number of elements increase, their size will decrease. Atomic size increase with increase in atomic number of elements as we move top to bottom in a group. It means in a group from top to bottom, the atomic size also increases with increasing atomic number. Ionization enthalpy or ionization energy or ionization potential. The minimum energy required to remove the most loosely bound electron from an isolated gaseous atom to form gaseous cation is known as ionization enthalpy or energy, and the potential difference that creates this energy is known as ionization potential. 1 volt ionization potential is equal to 1 electron volt or 1.6 into 10 to the power minus 19 joule ionization energy. Variation in ionization energy in periodic table. As we move from left to right in a period, the atomic size decreases with increase in atomic number, and therefore more energy required to remove the electron from atom of element. Therefore, ionization energy increase from left to right in a period as atomic number increase. As we move from top to bottom in a group, the ionization energy decrease as the atomic size increase. It means in period from left to right, ionization energy generally increase, and in group from top to bottom, ionization energy generally decrease. Electron gain enthalpy or electron affinity. The energy released when a neutral isolated gaseous atom accepts an extra electron to form a gaseous anion. When an atom in gaseous state accepts an extra electron to form an anion in gaseous state and release some energy, then this released energy is known as electron affinity. Its unit is joule or calorie. When we move from left to right in a period, the size decreases with increase in atomic number, and therefore electron affinity will also decrease. As we move from top to bottom in a group, the size increase with increase in atomic number and therefore electron affinity will also increase. Chlorine has Chlorine has highest electron affinity which is equal to 349 joule per mole. Next point is electronegativity. The tendency of an atom to attract the shared pair of electrons towards itself in a covalent bond is known as electronegativity. It has no unit. Different elements are assigned a value. Chlorine is assigned the highest electronegative value which is equal to 4. When we move left to right in a period, the atomic size decrease in increase in atomic number and therefore with decreased size the tendency of attracting electrons increase. That means electronegativity increase from left to right in a period. As we move from top to bottom in a group, the atomic number increase resulting in decrease of tendency of attracting electrons and therefore electronegativity will decrease. Now we can simplify property variation in period from left to right, variation in group from top to bottom. Atomic size in a period from left to right will decrease while atomic size in a group from top to bottom will increase. In the same way, again, ionization energy in a period from left to right will increase and in a group from top to bottom it will decrease. Electron affinity in a period from left to right will decrease and in a group from top to bottom will increase. Or electronegativity in a period from left to right will increase and in a group from top to bottom it will decrease. You again can simplify the atomic size is directly proportional to electron affinity and it is inversely proportional to ionization energy and electronegativity. So it is simple way to learn the relationship between atomic size, electron affinity, ionization energy and electronegativity. Classification of elements on the basis of their electronic configuration. On the basis of electronic configuration, elements are classified into 4 blocks. Periodic table. In periodic table, add S block elements, P block elements, D block elements and F block elements. Number 1, we will discuss now the S block elements. Elements in which the last electron enters in S orbital of their respective outermost shell or valence shell are called S block elements. Elements of group 1 or first A and group 2 or second A are known as S-block elements. General characteristics of S-block elements. Number one, general valence shell electronic configuration of S-block elements is NS1 to 2. That means NS1 for first A elements and NS2 for second A elements. Second, general valency of these elements are for first elements 1 and for group second elements 2. Means the elements of first A are generally having valency 1 and elements put in second A group are having general valency 2. Third, they have low ionization energy. Means the S-block elements have low ionization energy. Next, they are highly electropositive in character. Means they easily fall the cations. Fifth, they are soft metals with low melting and boiling points. Means these are soft metals and having low melting and boiling points. Next, they are very reactive metals and reactivity increase from top to bottom in a group. 7. They are never found pure in nature as they are highly reactive. It means they are all found in combined with other elements. 8. Generally, these elements burn with colored flame. 9. They are strong reducing agents. 10. They are good conductor of heat and electricity. 11. They generally form ionic compounds. For example, for sodium, which is having atomic number 11 and put in an element of a first A group is having electronic vinyas first S2, 2S2, 2p6, 3S1. The valence shell having the 3S1 electronic configuration. In the same way, magnesium with the atomic number 12, which is an element of second A group, is having electronic configuration first S2, 2S2, 2p6, 3S2. The valence shell electronic configuration of this element is 3S2. Okay. Now, p-block elements. Elements in which the last electron enter in p orbital of their respective valence shell are known as p-block elements. Last electron enters in p orbital, then that kind of elements are known as p-block elements. General characteristics of p-block elements. Number 1. General electronic configuration of valence shell of these elements is NS2 and P1 to 6. For boron with atomic number 5, electronic configuration is 1s2, 2s2, 2p1. It is placed in third A group or in 13th group. For carbon with atomic number 6, the electronic configuration is first S2, 2s2, 2p2. element of carbon is placed in fourth group, or we can say in 14th group. Nitrogen with atomic number 7 is having electronic configuration first S2, 2s2, 2p3. It is placed in fifth group or in 15th group. Oxygen with atomic number 8 having electronic configuration first S2, 2s2, 2p4, and it is placed in 6th A group or in 16th group. Chlorine with atomic number 9 is having electronic configuration first S2, 2s2, 2p5. It is placed in 7th A group or in 17th group. Neon with atomic number 10 is having electronic configuration first S2, 2s2, 2p6. It is placed in 0 group or in 18th group. Their ionization energy are relatively higher than S block elements. 3. Their valency vary from 1 to 4. 4. Their atomic size are relatively smaller than S block elements. 5. Their electronegativity and electron affinity are generally high. 6. They are strong oxidizing agents. 7. They generally form covalent compounds. Now, next we will discuss the d block elements. Elements in which last electron enters in d orbital are known as d block elements. Since their properties are in midway between S block elements and P block elements, therefore these elements are also known as transition elements. In these elements, there is transfer of electrons within d orbitals, and this transition is called dd transition. General characteristics of d block elements. First, their general outermost electronic configuration is n-1 d1 to 10 and s0 to 2. For scandium atomic number 21, the electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p6, 3d1, 4s2. Titanium 22, the outer electronic configuration is 3d2, 4s2. Vanadium 23, 3d3, 4s2. Okay. For chromium 24, 3d5, 4s2. Manganese 25, 3d5, 4s2. Iron 26, 3d6, 4s2. Cobalt 27, 3d7, 4s2. Nickel 28, 3d8, 4s2. Copper 29, 3d10, 4s2. Zinc 30, 3d10, 4s2. Number 2, they shows variable valence. 3, their ionization energy lie between S block and P block elements. 4, their ions are generally colored in nature. 5, their atomic size lie between S block and P block elements. 6, they generally form colored and complex compounds. 7. Except mercury, all elements are hard and metals. 8. They are catalysts in nature. They are good catalysts. 9. They are generally paramagnetic in nature. Explanation. Zinc 30, outermost, outer electronegativity 10, 4s2, cadmium 48, 4d10, 5s2, mercury this, 5d10, 6s2, and are not these zinc 30, cadmium 48, mercury 80, and Cn 112 are not transition elements because these elements do not exhibit DD transition, and last electron also enters in s orbital, but due to similarity in property with d block elements, these are part of d block. These are part of d block, but these elements are not transition elements because d block elements and transition elements meaning is totally different. D block elements means the elements which are put in D block, and transition elements are those elements in which there is DD transition, because these elements which are given over here, zinc, cadmium, mercury and Cn, don't exhibit these transitions, therefore these elements are not transition elements. Next, F block elements. Elements in which last electron enter in f orbital are known as f block elements. These elements are also known as inner transition elements. These elements are classified in as, as lanthanoids and actinoids series. General characteristics of a block elements. 1. General outer electronic configuration of these elements is N-2 F1 to 14, N-1 S2P6 D1 NS2. For lanthanoids, N is equal to 6, and for actinoids, N is equal to 7. Lanthanoid series from C58 to Lu71. The cerium Ce is having 4F1, 5S2, P6D1, 6S2, and in the same way Lu71 is having 4F1, 5F50, 5S2, P6D1, 6S2 is 14. Okay, this is 14. And octanoid, thorium, thorium, 5F1, 4S2, P6D1, 7S2, 5F14, 6S2, P6D1, 7S2. This is 4F14. 2. They show variable valency. 3. They generally form complex and colored ions. 4. Their compounds are ionic and complex and colored. 5. They have high boiling and melting points. Now we will discuss relation between ionic radii and charge on ion. Ionic radii will decrease will increase in positive charge and ionic radii will increase with increase in negative charge. Therefore, the size of N3 minus is greater than O2 minus, is greater than F minus, is greater than Na plus, is greater than Mg2 plus, and is greater than Al3 plus. Shielding or screening effect. In a multi-electron atom, in multi-electron atoms, the electron in valence shell or outermost shell experience an attractive force from the nucleus and a repulsive force from the electron in the inner shell. Electrons present in the inner shell. The repulsive force felt by the valence shell from electrons in inner shell is called the shielding or screening effect. The actual charge felt by the valence shell electrons is called effective nuclear charge ZEF. So, effective nuclear charge is equal to total nuclear charge minus shielding or screening constant. Today we have discussed classification of elements in periodic table, the periodic properties like atomic size, electronegativity, electron affinity, and ionization energy, and their variations in periodic table in groups and periods. We also discussed the screening or shielding effect. Thank you.